You might recall the Pythagorean theorem, a squared plus b squared equals c squared. Now a and b are always legs of the right triangle. They're the sides that make the right angle. C is always opposite the right angle. It's always the longest side, and it's called the hypotenuse. Using the Pythagorean theorem, let's find the length of the missing side in the right triangle. Here I have a B. This must be side A, and this must be side C. So I have a squared plus b squared equals c squared is 24 squared plus b squared equals 25 squared. Now I have a 24 squared. If you'd like, we can put this in the calculator. Let's go back to the home screen. 24 squared equals 576 plus b squared equals 25 squared, which is 625. Now I want to isolate my b squared, so I'm going to subtract 576 from 625. I get 49. Now, solving this, I would take the square root of both sides. So that's the square root of b squared and the square root of 49. And of course, we have to put the plus minus in there. So b is plus or minus 7. Now, in the context of this problem, when we're talking about b being a length of a leg, the answer -7 doesn't make sense. So we throw the -7 out, and b equals 7 is our only solution. A right triangle has legs A and B with hypotenuse C. Find the length of the missing side. So here, we don't have a picture, but we can go ahead and draw one on our own. Here's our right angle, and we have legs A and B. Remember, the legs are the sides that make up the right angle. And we have to find the hypotenuse, which we know is C. So a squared plus b squared equals c squared gives me 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. So 25 is c squared. I'll take the square root of both sides, remembering the plus minus, and c equals plus or minus 5. Again, in the context of this problem, it doesn't make sense to have a negative length. So I'm going to throw out the -5 and keep just a +5 for my solution. Now we have the distance formula. The distance d between the points x1, y1 and x2, y2 in the xy plane is this formula. D equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. This comes directly from the Pythagorean theorem. If we would have these 2 points in the plane, let's call this point x2, y2, and this point x1, y1. Then we can find the distance between those points by using the Pythagorean theorem. Dropping a perpendicular and moving out horizontally to make that right angle. Now the length of this side is going to be x2 minus x1. The length of this side is going to be y2 minus y1. So now we need to find out the length of this side. We'll call it d, which is the distance between those 2 points. So using the Pythagorean theorem, where this is a and this is b, I would have x2 minus x1 squared plus y2 minus y1 squared, and that equals my d squared, my hypotenuse. Now to get the d by itself, I simply take the square root of both sides. And I know I'm not going to put the minus because this is talking about a length or a distance which can't be negative. So that gives me my distance formula, which came directly from my Pythagorean theorem. Let's find the length of the line segment. Here I could just go ahead and draw a right triangle and use Pythagorean theorem, but let's go ahead and practice our formula for distance. Remember, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have here the square root of, well, let's find our points here. Our points here are -2, 1, and 2, 3. So this gives me the x of the second point, which is 2, minus the x of the first point, which is a -2, so it makes it a +2 quantity squared, plus y2, which is 3, minus y1, which is 1, all squared. So d is the square root of 2 plus 2, which is 4, squared, plus 3 minus 1, which is 2, squared, is 4. So d is the square root of 20, which I know I'm going to have to simplify. Remember that 20 is 2 times 10, 10 is 2 times 5. So I'll have the square root of 2 squared times the square root of 5, which gives me 2 square roots of 5 for the exact length of that line segment. Let's find the distance between these points. Now here I'm not going to have a graph. I'm not worried about graphing it. Let's just use the distance formula. So the distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So d is going to be the square root of 4 minus -1, so it makes it 4 plus 1 quantity squared, plus y2 minus y1, so that's 10 minus 2 quantity squared. So I have the square root of this is 5 squared plus 10 minus 2 is 8 squared. So the distance is going to equal 25 plus 64 in my square root, which is the square root of 89. Now 89 is not going to break down, so that's just our distance, the square root of 89. The diagonal of a television. A rectangular television screen is 11.4 inches by 15.2 inches. Find the diagonal of the television screen. So here we can draw a picture. It's 11.4 inches by 15.2. And they want to know what the diagonal of that television screen is. So again, we're using the Pythagorean theorem. This is A, this is B, and we're finding C. So 11.4 squared plus 15.2 squared equals my C squared. Let's use our calculator. We have 11.4 squared is 129.96, and 15.2 squared is 231.04, and I'm going to add those together. And that gives me 361. And we need to take the square root of that, so second square root, and we can hit second answer right there, and it's going to take the square root of the answer from my last line, the 361, and I get 19. So we have here 19 inches as our answer. So that covers this lesson. Go ahead and try your homework and be sure to let me know if you have questions.